Right. And we are live. Let me go make sure that YouTube is up and running. Yup, there it is. Hello. I see there was people in chat before I was. Kinda slacking as a streamer there. But yeah, so to kind of update, what is this? Why do I have people in chat? I've been back streaming for like one other stream after months of not streaming. What's going on here? But yeah, no, I've decided that like I would like to try keeping a consistent schedule of like Tuesdays and Thursday nights. Maybe a time on the weekends, but I can't promise that. But yeah, just because this is fun. I like doing it, so I might as well make it consistent so other people can enjoy me doing it too, you know? But yeah, so last time I have this idea for multi-stage generative programming that I wanted to try out. I tried seeing if Lua would be a good option for doing that, just to like test it out, because I didn't want to like commit to anything like creating a custom scripting language for it. Throughout the course of the stream, you watched me devolve into madness, where I basically came to the conclusion, no, I don't like any of the existing scripting languages, we're just going to create our own. And that is what we did. I actually had a semi-working scripting language by the end of the stream. Like, this is technically a semi-working scripting language. If I put curly braces here, I was messing around with different syntaxes, but if I put the body of this function in curly braces, maybe put a return there as well, this might actually run and compile. Okay, no. Expected semicolon after every root scoop found an open parenthesis. Where is it complaining about this? Because my error messages are terrible. He's complaining about it here? Or maybe we consume that semicolon. I don't know. Do we consume the semicolon? No, but it said opening parenthesis. What's going on there? I'm gonna figure out why this isn't working real fast. And then, what I'm going to do is I have a to-do list that we'll be able to burn through rather quickly here, because I've decided, well, this is just a compile time only language, which means I don't need to care about performance that much. Outside of just like, I want dev iterations to be fast, so like, as long as it compiles as like similarly fast to, as long as it's faster than a C++ compile, I'll be happy. It can't compile faster than C, because we are literally going to be outputting C files. So whatever we do is in addition to the cost of a regular optimizing C compiler. But that being said, our scripting language, like, if it compiles faster than Rust, we'll be fine. But single pass, run all the scripts. It's not going to be slow by any means, no matter what we do, basically. Hello. So, where's my to-do list? Right. So, first thing we need to do is I need to actually finish writing a compiler. So right now, this very simple scripting language is literally just is just consuming tokens, and then directly outputting output in in the parser itself, basically. Like, this is both a parser and actually running the code. And I nearly, maybe, have not necessarily closures working, but like inline function definitions working. And the way it works is incredibly cursed, because we literally just find the function, and then we figure out if this is a function with just one expression or if it is a curly brace expression. And then we just go, okay, so this function either ends with a closing brace or semicolon. I've realized that semicolon isn't really ideal, because if I wanted to define a function with a single expression like this, I would have to put 2 semicolons. One is the end of the function, the other is, you know, the end of this line of code. So that's not really viable as a grammar. I've loosely considered copying Rust's closure format just straight up, because this is kind of Rust-inspired grammar, but I decided, no, I want to use the fn syntax to designate when functions start. Almost out of water. Well, hopefully that makes my voice not as scratchy. Anyways. But yeah, so what I'm trying to do is I'm just trying to, like, go until we find a closing token, accounting for the fact that we can have, like, nested scopes, and then just, like, store that range of the function, and then just redirect. When we call this function, we would redirect the parser to parse the body of the function. Which I don't think I actually have returns implemented correctly either. So I think currently with how it's implemented, we would jump to the beginning of the function would execute, and then the program would continue executing past the end of the function. I think that's what would happen. Okay. So it's straight up not worth trying to finish getting that version of the scripting language working. Yeah. So a couple other things on the to-do list. So first we need to implement an intermediate representation so that instead of doing weird function syntaxes, I could just have the function itself just, like, we want to be able to define stuff like this. So this is a function that takes in 2 parameters, A and B. It captures C from the environment, closure, or capturing lambda, whatever you want to call it. It gets member C, member F, and then calls member F with arguments A, B. In this case, member F is the add function defined by the environment. And yes, all of this code works except for the lambdas. You can actually set the environment variable function add as a member variable and then call it. Like, that all works. I'm actually surprised with how fast I got a ton of this stuff working. It turns out, if you code stuff in the same way that JavaScript was coded, you can make languages really fast. I've been working on this for 2 days, and it's like I nearly have all my base level stuff working. And that's not even like 2 days of like it's actually my job. This is like 1 4-hour stream, me like working on it for 2 hours before work. If that, it might have been 1 hour and 30 minutes or just 1 hour, and then today, like, we have not worked on this at all. It turns out it's a lot easier to make languages when you don't JIT compile everything. Does Mio not the type system? What is Mio? What is the Mio language? It's calling it Italian and Spanish. I'm gonna say coding language. minimalistic programming language written in the Python programming language. I want my scripting system to be faster than Python, so I'm not going to use the scripting system implemented in Python. Just, yeah. Minimalistic I/O programming language. What is an I/O programming language? Number equals fact, method, reduce, functional. I like functional. Block. As in a scope, like a block. Yeah, this does look like Python. Install. Fact implemented in Python. Anything but JavaScript's type system. So here's the thing. We can have JavaScript's type system slightly better oriented. We're not going to have date time. Only compiler side, like for macros and whatnot. I could tolerate that. Well, I'm not really going the JavaScript type system. I'm more inspired by the Lua type system. Now, I don't want to do that weird stuff where the tables are also arrays. Like you have the same object type for key value and arrays. No, we're just going to have arrays and objects be their own things. But yeah, let's get to it. Oh yeah, right. We're gonna make lambdas capture variables by copying them. Let the garbage collector take care of the rest. And for the first time in my life ever, I've actually considered writing a garbage collector. Now, since we need this to be fast, but not blazingly fast, as the web devs like to say, we're just going to have this be just like the simplest possible mark and sweep garbage collector. Yeah. So this is our to-do list. IR, and then we create we make our IR, we do this, and then we don't need to implement a garbage collector. We technically, as an MVP, could just memory leak while we're defining stuff. So I think I'm gonna put interning strings here. So we're gonna parse our IR while interning our like symbols, basically, interning strings. And instead of RCFSL variables, we're going to have all of our objects, so all of our value types are going to be stored in place, so those are floats, ints, booleans, those are all going to be just stored in place inside of objects. But then anything larger, like an object or an array, all of those are going to have their own array within the runtime, and then when a value stores it, what they're actually going to store is just a like usize index that points to the indice in one of those arrays that value is stored in. That way we like, here's where all of our data is stored, here's how we reference that data. Super clean. And then we just do a GC mark and sweep over everything, starting from our stack values and whatnot. Yeah, basically just starting from our stack. And then we make, yeah, the lambdas, this is just an implementation detail of how we're going to implement the way lambdas work. So I'm going to actually put this up here before we create the garbage collector. And in here, I'm going to say implement VM for language. And I think at this moment, IR should be designed around this being a stack machine. We're just gonna do stack machine, because stack machine is easy. Is very easy. So here's the stage at which we're going to rewrite evaluator to instead be a single pass cursor compiler to generate intermediate representation. Okay. This also immediately gets rid of all this weird stuff with like function arguments and not necessarily, well, some of the weird stuff I was considering doing for scopes. Yeah. So let's get into it. Let's design our intermediate representation first. What operations do we currently need? Let's look at our bytecode here. So if we go line by line, the way that I plan on having this work are the instruction set for our compile time virtual machine. Now, I'm not going to do anything like register values or whatnot. Instead, we need to have a concept of Actually, let's look at an amazing example eyes feel weird. Good. You know when your eyes are like the slightest bit watery? So like messes with you and makes your vision very slightly blurry, but you're like, alright, we're gonna do an eye check. 20 feet in the distance, stare at it for 20 seconds. Okay, we're good. Actually, let's look at bytecode. Bytecode reference. That is a website. They have stack and registers. Blue employs 2 stacks. The call info stack tracks activation frames. There's a secondary stack, L stack, that is in a value array of T value objects. Call info objects. Register A, register B, register C. The program counter. I guess they do direct jumps. Whatnot, which I guess I do have to account for control flow at some point. We have move that copies the value between 2 registers. Okay, calls them to register. I don't want to deal with register allocation, so do I copy WebAssembly instead? Because WebAssembly is technically a stack machine. A pure stack machine. I think with no registers. Actually, no, they have like this weird, like, register system. But yeah, for our stack machine, the stack machine is purely used to pass arguments and return value. Everything else. Everything else is stored in stack machine, purely used to pass arguments and return values around. Everything else is stored within the global object. Yeah, stored within the global object or the stack frame. Everything is stored within the global object or the stack frame object. Compile time only, we're not going to worry about sandboxing whatsoever. In fact, we want the opposite of sandboxing. We want it to be really easy to do anything we need to actually compile our code and whatnot. Hello, how's it going? It's always good to be good. I'm doing well as well. I'm getting my needed fix of language programming while telling myself that it's justified because we're just making it MVP here, and it's just an experiment. No greater plans than that yet. Until I decide it's good and decide to make an engine based off of it. But I don't need to make an engine based off of it if it turns out to be good. I'm just like, it might be more ergonomic than using Rust to directly interact with automatically generated C bindings for the LunarG Vulkan SDK. the custom coding language. More ergonomic. More efficient, of course. All in the off time between actually working a full-time job, which hopefully they don't need me. I wonder if they were able to ship tonight. That would be... I'm not seeing an announcement that they shipped tonight, so I'm gonna assume we did not ship. We ship tomorrow, though. Old CI is passing down, that's good. Actually, no, they're still in a huddle. They're still trying to ship. Hopefully, I do not get called in because my stuff broke. That would be very funny. I think it's all working, though. Okay. Now, do we want to have operands specifically for putting things in global objects? Or not? In any case, stack machines are a great way to have implicit IR, basically. Have implicit operation. Now, it is really, really important to have the game that I currently work on. So I got a job at a different studio than the one I was working at before, and this one has a released game, which is actually really fun because I can push updates to like a large audience. And that feels really good. That was something that I've been missing for a while because I've only worked on like pre-revenue, like pre-actually having customer startups, and now I'm working for a startup that actually has a shipped game that's been out for like a couple years, and so like when my code gets merged into main and we push, like that's actually being experienced by people. Justify this as being eventually usable there. So, I'm actually telling myself that I'm not working on Brain at the moment, so I have less pressure to make things perfect. This is a different thing that might evolve into a version of the Brain engine, but right now, kind of the mentality that I'm going through is like, it's cool and all that I spent 5 years working on the same project. I want to have more things to show for the amount of time I spend on things. So my goal right now, I'm just clearing out like Discord notifications for my own stream. My goal right now is to learn how to ship things. I want to release the things I work on a short timeline, and I want those things to be quality. I don't want to ship slop, but like I want to actually be making things that people experience, because that's what makes me happy, is when people use the things I make or experience the things I make, and that affects them positively. Like, I can sit in my cave all day and be like, I'm going to change the world, but it's like, I'm saying I'm going to, not I am. And I want to be able to say I am, like, making an impact. Favorite project management tools? What is Project Man now? I've used Notion a bit in the past, but that's something I probably should get better at. Honestly, my most successful project management tool so far has been create a shared Google Doc, set up like a to-do list or 3, and then just like write your notes down there, have everything in one giant doc, and then just like be on voice calls with the people you're working with, if you are working with people, and just like if it's less complicated, it works better. Like, I've had moments in the past before where like I set up like this entire Notion system for my entire company, and then nobody uses it. And I've spent like a couple days or a week purely on like coming up with this entire project management system, and all of that time was objectively wasted because nobody used it. Like, if they did use it, maybe they would have been more productive, but they're like, no, I don't want to fill out like a task. Like, they just want to do the thing. So yeah, I'm kind of like, I'm a little bit of a planning minimalist, to where you can only plan out so much of a program before you've actually delved into the code, and how you're gonna, unless it's something you've made before, you won't know how to make it. And like, you're not making stuff you've already made too often because you've already made it. And then you're just talking about refactors, and like refactors, you don't know how you're going to do the refactor because you've never done that refactor before. I have these operands be copy, clone, copy, clone. That seems like a good starter set of operands. And then, what do you need to work with here? So it's a stack machine. See, I like how the Subnautica devs made their Trello board public so we could all see the cards' progress as they worked on them. Yeah, and that's something similar to what I would do if I was working on a public project. In fact, I did that for Brain Engine. I had a public Notion, essentially Trello board. Not that I updated it too often. I think I might use like a GitHub project in the future, but GitHub projects, the problem with GitHub projects is there's a ton of friction because you have to create an issue for every single, you have to create an issue for every single item in that board, and then then you don't want that mixing with your regular issue system. So now you need to put a lot of effort into actually making a good issue. And then what I wanted to do was new task name, and then we're done. Yeah. Also, I'm pretty happy about this. I can't say proud because I didn't make it, but we got the Project Hail Mary guy. And if my audio is weird, it's because I'm printing another one behind me. Okay. Okay, so we have, when we're pushing variables onto step, This consumes 1. What syntax should I use for this? Consumes 1, which is 0. This is for cleaning unused values off the stack. So we have that. That is the one operand we know we have. I know a lot of stack machines there's such thing as an MVP stack machine operand. Let's see if the Eat Glue GPT has a good explanation. Yeah, I know how a stack machine works. We push this value, we push that value, and then we add. Now, how do we want to deal with to convince my software engineering 2 class teacher to switch from using Trello from the project management tool that they'd been using by showing them some cupboard as a real world example? That's cool. Were they trying to use like not Atlassian, what am I thinking of? It's the Microsoft Azure is what I'm thinking of. Man, that thing is so clunky. Almost want to make this consume, like we can push a literal onto the stack. So it consumes 0, pushes 1. Something. Let's see, since I'm already thinking about doing, yeah. We're gonna push constants, and I'm trying to keep the op size as low as possible. We're gonna keep this at 128 bits maximum. 8 bytes. Actually, not 8 bytes, 16 bytes? Yeah. Size of 2 pointers. And we can have bool constant, we have an int constant, we can have constants I64, we can have float constants. Float is going to be f64, and can have this be equal to a symbol ID. What other types do we use? String, int, float, true, false. Okay, so that's it. Do I want to have function constants? Push a function defined by this script onto the stack. Will really look as if it used by actual programmers and software's dev thing. It always feels very vaporware sounding explaining a software tool. Yeah. I like that at least something from some form of automod actually started blocking the seller bots, because like those things have been on Twitch for forever, but like I've only ever had them like re-blocked since literally my last stream 2 days ago. Literal years of streaming until they implemented that. Which, improving as a platform? Thinkable. We push a function onto the stack to be able to call it. Bit of whatever on my drawing tablet screen is really bugging me. Those are all of our constants. Now, thinking about it, your difference between a function definition and a So since functions are first class and they're basically all going to be capturing lambdas, I'm not really going to have a definition of functions that aren't capturing lambdas. We need to have two operations. Actually, what I can do here is we can just go down this script line by line and we can figure out, like, what does this script need. So first off, we have a constant. We are currently able to push a constant int onto the stack. So now we've pushed a constant integer onto the stack. Now, we need to store this constant 2 into a variable a, which means we need to we are cooking up a compile time language that we're going to use to generate scripts and programs that actually get compiled to a binary. So we run this language and it's supposed to generate C code, and then we can compile that C code and run that C code. And the reason for this is extreme amounts of metaprogramming. Wait, do I have viewers on Twitch as well? That never happens. Ever. Maybe I actually titled stuff interestingly, well. Like, for once. That never happens. Anyways, so we need some way to say, store this into a global value, or an object. Or insert a value into an object, basically. Or, not even insert. So if we're doing the whole, like, dynamic programming thing, then what we need to do is just, like, a set member operation, where we need to consume two stack variables. Why compile it to C instead of Rust, since you're writing it in Rust? Well, it's because I actually want to write things in C, but C doesn't have all the features I want. So this is my way of adding the features to C that I want. And Rust is a very easy language to write things in, at least for me. But it's not what I want to write a full, like, I want to make just a fun engine to play around with. It doesn't need to be like memory safe or any of like these other like things. But what I want to do with the engine a ton is interact with like kernel level APIs and whatnot, and it's actually like really unergonomic to do that in Rust. Like, I can actually give you an example. So this is a different small engine I've been working on in my free time, which actually, before I show you the code, you can just cargo run this, and it should compile and run, because I haven't changed anything since the last time. Well, I've done something to break it, so it's not running. Actually, if I just... go to resources, since this is the mod that's failing. Anyways, this is like a small toy engine that I just wanted to mess around with stuff in. And let's go to the graphics folder. And here's what it looks like to code Vulkan in Rust. If you're not using a Vulkan wrapper, now, I don't know, I have mixed feelings on like, oh, I want to use this API, let me find the safe Rust bindings for that API, which in this case, it would be the Ash bindings for Rust. Not Rust, Vulkan, basically. And yeah, instead I just want to do like, I did like just cbind gen, I generated my own Rust Vulkan library from just C header files. And I want to be able to automatically generate header files for like a language, but then use them ergonomically. And it was like not ergonomic to write this at all. And like I'm comfortable writing C style stuff, but like Rust made it actively harder to write this code instead of easier. See, but it could have been easier to write this if I was just writing in C than if I was writing in Rust. And I want to be doing a lot of this. Like, for example, I'm not even using like any windowing system, I'm just using the raw Win32 API, which is also a C API. Here's the thing, everything has a C API. And if I can access the C APIs and maybe automatically generate better bindings for those, because I'm making basically like a super like a super ergonomic macro programming language, which is what I'm working on, then I'll basically be able to write in C. This is the experiment, is I want to be able to write in C, I want to have Rust style like tagged unions, discriminated unions, and like match statements. So I want C, but those like 3 Rust features. And then I can also build on top of that and have like errors as return values as like unions and whatnot. Yeah, so that's the idea behind the languages. I want to essentially rewrite this project in my own language instead of in Rust, which I know you never hear Rust users go like, oh, I want to rewrite this in something other than Rust. But I'm just that, so you know how like the extremes meet in the middle? Like I've gone so far down the rewrite in Rust that I am now on rewrite it in C. But not even rewrite it in C, right? Rewrite it in like my own thing. So what's hard about it in Rust? One of the things is you have to wrap everything in unsafe, and like there's this like Rust cultural thing where like they see this macro in here and they go, oh no, don't use that, that's unsafe. Rust is supposed to be memory safe, which TLDR, I mean, memory safe means that guaranteed that an attacker can't do remote code execution vulnerability on you, or like use after free and those sort of things. Which like for my toy game engine, I don't need that. That's complete overkill. Maybe when I'm writing a server backend, that's when it matters. It mostly matters for server backends. Stuff that you're going to expose directly to attack surfaces. But for like my gameplay code doesn't really matter, unless that gameplay code is like exposed to attack surfaces, my players. Which I can worry about that when we get to that point. But yeah, you have to do unsafe, and then it's really annoying with like Rust pointer typecasting really isn't ergonomic at all. You have to type like as and then pointer, and then you have to manually specify if it's mutable or constant, and then the actual thing. And then that's not too bad, I guess, because that's just one. But if we go over to graphics, for instance, there's parts of this code that have to cast to void. And the really annoying thing about Rust is it doesn't let you cast directly to void from, like, let's say I have a reference to this. You can cast references to pointers, and then you can cast that pointer to a void pointer. And it's in C, they use void pointers, and void pointers are ergonomic because, if I'm remembering correctly, you don't have to cast to void pointer. Yes, when you have a void pointer, you have to explicitly cast it to other types, but that makes sense because you're saying, hey, this void pointer is this type. But you don't really have to tell like the C compiler, hey, if I'm putting any other type into a void, it's very obvious that like I'm using void as like a wildcard here. But in Rust, instead of just throwing this, Rust can implicitly cast references to pointers, but it can't implicitly cast void pointers. It cannot implicitly cast references to void pointers, so you have to do like all of this garbage. And then the Rust library uses a ton of bit field flags. So there will be cases where you're like bit oring and bit anding stuff and then comparing flags, and you can't even like directly like check like the truthness of a flag field. You have to check like, so we're gonna or and all these bit fields together, and then we have to check greater than 0. So basically, I could keep listing reasons, but there's a lot of reasons why you can write Rust as C code, basically. You can ignore everything that makes Rust Rust, but the language fights you constantly because it's explicitly designed to get around like the fact that all of that is not safe to do, and then make the safe version of that more efficient to do or whatever. Yeah. I mean, the whole point of scoping unsafe is to explicit blocks is to build safe ergonomic extractions around it. That way, you know, if you get a sigful or similar, you don't have to look at the unsafe faults. Yes, this is true. But for the type of projects I want to do right now, I don't want to make safe abstractions. I want to be dealing with no abstraction land. And then of course you build up abstractions on top of no abstraction land. But like, I don't want to have to create my own abstraction for each one of these little things, and I don't want to use an existing abstraction. Like, I want to do this project to better learn how Rust works and have full control over all of that. Because if I use an abstraction, in very small ways I'm losing control. Especially with things like the windowing system. I've never written a windowing system before. I really enjoyed writing a windowing system. Because, like, I just have control over... Yeah, I just have control. I want to figure out why this isn't compiling. Type alias without a body. Oh, so I just need to delete them. Don't be surprised when you use ergonomics. Well, if I was writing in C, I'm not worried about losing ergonomics. I'm annoyed by the language actively fighting me. And I don't want to use C because it doesn't have enough infrastructure for me to write the sort of abstractions that I want to. And quite frankly, I've written enough C++. I don't like the way they provide abstractions over it, because I really like metaprogramming. And C++ has the flavor of metaprogramming that I like, but the syntax and language that they give you that metaprogramming in is really bad. Here was me, like, starting to think about, like, how I was actually going to start abstracting my actual game objects and whatnot. C++. The single plus. But specifically single plus, we're not going to use P's there. There we go. There's my Vulkan triangle with that you can't resize, so let's bring that back. The windowing system supports you resizing it just fine. Don't let go of the window. But yeah, so I want to rewrite that in a more ergonomic way, maybe. So I might just stick with just crusting it, like C-rusting it. But I thought, why not? I've had this idea knocking around in my brain for like over a year now of like this generator language style thing. So why don't I just spend like a week or two experimenting with this idea, and then just try to get it working as fast as possible, not trying to make it perfect. You can see how well I'm achieving that. We're getting a little bit off track. I'm not in university or college, as we call it over here in the land that claims to be free. I dropped out 2 years in, so I've been out of college for a while now. I work at a VR game studio. It's a game called Veil. It's a fun game. You should go play it. I was hired very recently and been working on basically dealing with tech debt, basically. It's pretty fun. Oh, Peter, I'm streaming right now. That door is supposed to be locked, by the way. Please close the door when you... Okay. It looks like it was good that, it's good it was unlocked, because he needed to steal the plunger. I don't know why the plunger was in here. But I'm gonna go lock that door. He might have lockpicked it, actually, yeah. Did that? There's a chance the handle was on stream, so I might be able to go back and check that. He might have lockpicked it. Second, I thought he was about to take a piss with the door open. Okay, so when we set a member of a structure, storage for random stuff, you have to be vigilant of this. So the weird thing is, like, I've been on the verge of moving out again for like a year at this point. That's partially why I switched to a different job, is because like I really need to move out. So the storage space, the thing being stored is me. Like, this is not necessarily my room. This is where I am being stored. Okay, so I think we evaluate, in terms of stack machine, we should first evaluate the value for the object that we want to... the target object that we want to set a value on, the label, which how do I want to define? We'll go C style here. Object, target, string, label, and then value. Then this pushes none. That's the value of a member on a target structure. For the sake of consistency, we're going to say that copy consumes a value and then pushes value. Say that duplicates the last value on the stack. Then when we get a member of a structure, this consumes object target and then a member label, and then it pushes a value. This gets the value of a member on the target structure. Now, this accounts for all of this, and the reason why I say this accounts for all of that is let's we push the global object onto the stack. Now, is her variable scopes, am I going to have those? Am I going to have scopes as a runtime concept, or only as a parse time concept? I think I do. This is a reference to the global object. A reference to the top stack object, and this is a different stack, so we're making a stack machine right now. Yes, I've used several different distributions of Linux, including Arch, by the way. But since I'm a VR developer, I'm kind of stuck on Windows, because there isn't really any... There's no market of Linux VR games. Aside from, like, technically, this is a fork of Linux, this thing. Android, that is a Unix machine. When the Steam Frame releases, that's going to be great, because that actually... Steam Frame is just straight up 64-bit Linux on ARM. amazing. I really hope it gets a massive share of users so that I can have an excuse to develop for Linux. That would be amazing. But I'm not escaping Windows anytime soon, unfortunately. I'm still holding on to Windows 10 for now because I don't want to have to deal with React in the start menu. Now, top stack object lights. For a higher one, define I. That's probably not very clear whatsoever, but I understand what it's saying, and that's what matters. The Resomat team members mentioned using Linux, so that might be somewhere to look for example. Well, that's the Resomat community, that's the Resomat community. So, okay, so the way that our stack machine is going to define this statement right here, let A equal 2, this is going to be the same as saying global A is equal to 2, basically, at least in this example. Now, if I said this in here, this would be the same as stack 0 B equals 3. And in here, this syntax, I'm just referencing the fact that we can set different sizes. Now, if we did stack -1 here, or just stack 1, that would actually be global. That would be the same as global. So, actually, stack is probably a member of the global object just for... No, I don't want to have weird variable stuff going on. Anyways, behind the scenes, it's just going to be an object. But that's how we're going to define these. So to make this happen, we're first going to push the global object onto the stack. So we're going to say global, and then we're going to push a string, intern string. So we're actually just going to push an integer onto the stack. Interned string value, and that string value is going to be we'll just say member label here. So we push the global and then we push the member label. So we've defined this part of the expression. Then we'll go off and calculate the expression however we need to. Stack expands, stack reduces. And now we have in this case, it's the constant that we push onto the stack, which would just be an int value of 2i. So then we run the set member operation, which will consume all of these values in reverse. And yeah, it consumes all of those, and now we have set A in the global scope to that value. It does the same thing for this one. So we have now defined all of the operands we need to be able to do those ones, plus more, because we have not used pop or copy. Now for let f equals this function, what we need to do is we need to be able to like instantiate a lambda. We're gonna call it closures. Lambda is an anonymous function. Closure is a function which closes over and captures variables. So this would be a closure. Actually gonna bring this back. Okay, so we need a way to instantiate closures. So what order of variables? I just realized these need to be triple comments, so they actually, if we ever run the Rust documentation commands, they'll generate properly. So, now, to instantiate a closure, what do we need? We need a reference, consumes and at some point we need to be able to define variable argument functions, because I just know that I'm going to have to create variable argument functions. But for our closure instantiations, those will always consume a known number of variables. So this will consume first a function those will consume a function definition, basically, like a lambda, a stateless representation of a function, and then this will then also consume just values, pushes call this a source function or const. And then this will push I'm gonna call this define closure. Like that, and I'm just thinking about when they're first class values, we won't ever call this with the value being not a function. Find, yeah. Assumes variable number of values, pushes a function makes an instance of a closure of a closure identified by index assumes values that we're going to say captures assumed values are captured by the Here's the thing, if I'm thinking about capturing variables from the local scope, I'm not necessarily pushing those to the stack. So I'm going to say this automatically captures local variables by name. Automatically captures variables by name from the local environment. Do I want to do stack object specifically? Wait a second. Stack object is meaningless. This is meaningless. Completely meaningless. Because, what a stack object? Well, I guess if we're doing stack object and then we're getting a member of the stack, like if we're doing get member, but what I would prefer to do is I guess it works. This works. Don't like it. But when we're setting values, this works. If we're finding values, this doesn't work. I think I don't even need to necessarily define these explicitly. I could just have global be a reserved name for objects. Like, you can't name an object global. Straight up, you can't name an object global. So what if we do find, and then find consumes string consumes a string variable name, pushes found this pushes the found value or nothing, because I do have a defined value type called nothing. Or this could throw an error if it doesn't find anything. We have this boolean here. Do I want we're just going to call this find or create object. If the object doesn't exist, we'll create it. And if a value isn't an object, then it fails. Find value, find or create object. And find or create object, both of these so this finds a value on the stack and this finds an object value on the stack or global scope. And if not found, creates object in highest. Current scope. So this will be very useful for when you do like that huge object chain where like you want to set like the nth member of a object. You can just set it and then that's automatically, all the sub objects are automatically created. Automatically captures variables by label from the local environment. Maybe, I don't know. Maybe there's a better way for that to actually capture values. Maybe like I could write a smarter parser that's just able to capture stuff from the environment, which is like know how to do that. But I don't know a simple way to do that, and I do know a simple way to do this, so we're just gonna do that. So we now have the ability to define closures, or instantiate closures, basically. Game Dev Brain is saying instantiate closure is the cleanest way to do that. Now, I'm not defining any operators at first. We're just going to have a bunch of different functions that are just intrinsics, and then when we actually call those intrinsics, that will be our operators. And when we finally define operators, which is what I was going to say before, those are just going to call the intrinsics. We're not going to have actual operators for doing that. I'm kind of recreating Udon. This is what Udon does, by the way. Actually, you want the absolute minimum stack machine definition. Here you go. This is VRChat Udon. We don't need no ops. You push a thing, you pop a thing, you jump if false, jump to a certain place. I guess this consumes one value and then jumps if that's false. Call an extern function because Udon doesn't actually have a way to call its own functions. You literally just jump around, which is why you have to mark Udon functions if they're recursive, because it doesn't actually have the concept of a real stack. Yeah, so here, let's have a call, and this call will consumes function callable. Function or object, anything that is callable. And then this pushes a single return value for now. Technically, we could do multiple return, but I don't want to deal with that. It's much more simple if we just have one return value. If you need to return more, you return an object, and that makes it super easy. Oh, the 3D printer just finished. Nice. I was like, why is a car horn going off? So we consume the function that we're calling it, then the arguments. This tracks with how my parser is going to construct. First we get the function, and then we get each one of the arguments in sequence. I know for a lot of times, stacking machines, they're like, oh, I'm gonna consume the arguments in reverse, in reverse order, because that's more efficient. No. We're just going to, it's just going to take them in the order you expect. Because why not? The first thing I'm going to do upon entering a function is create a new stack frame, push those values on, like, into the stack frame, not the stack machine stack, the stack frame. And then we won't have to worry about the order that they were pushed onto the stack in, because it just works. Yeah. Okay, and that's our call function. That's the way that we do things. Now, that everything. Well, we don't have jump commands. We don't need annotation stuff yet. I might change this to op_kind and then have metadata for operations, or we might store metadata for operations in a separate table, like a source map. That sounds like torture to deal with. We have copy, we have jump, indirect. Purpose this as a bytecode position. It jumps to it. So I guess jumps to the bytecode position given by the parameter. Ooh. We do need return. I just realized this. What does jump indirect do? It's a heap index from the parameter, reads a system U32 from it, interprets this as a bytecode position and jumps to it. Jumps to the bytecode position given by the parameters. So I guess this just isn't a stack machine value ever. I guess since I have other sized things, it doesn't, there's no extra cost to have This is technically a call indirect. And all ops are ops for a single function, so this will only be able to jump within the function, no jumping out of functions, no go-tos. Now, we don't need jump indirect yet. Always a return value pushed onto the stack before this command, even if it's a nothing value. That way, if somebody tries to set the value of an object to nothing, if we try to set the value of a member of an object to the result of a function that returns nothing, it will just have literally returned the value nothing. So we don't have to handle special cases for functions that don't return anything, because they do return something. They return nothing. And what did you return? Nothing. But there's a value there. No, I returned nothing. The value. Nothing. Do I sound insane? Honest answer. Honest question. I think this is our entire op tree, though. Call this function. Yeah, we're just gonna call it function for the ease of use. The body of this function is going to be a vector of op. We're gonna have a... This is where I decide if I want my interned string values. Yeah, we'll do this. This makes sense. This is a list of every string used in this function, interned by the runtime for GC of labels. Essentially, these are owning references to every single string used in the body of this function. That way we're not doing raw string operations for everything here. Strings will always be constants. Always. And we'll define intrinsic functions to do string operations. But, yeah. Did I come up with the type def for symbols? Here, we're gonna say symbol ID here. This is the interned names of variables to capture from the local scope when instantiated as a closure. And here's our parameters. Which might have type values at some point, but for now, just is what to label arguments. Is what to label our arguments before the function begins. This handles capturing variables. This handles garbage collection of all of our captured strings. This handles our parameter names. Yeah. So when we parse a script, what we're essentially going to do, when we load a script, we're going to get a number of functions. thinking more about this garbage collector and how the garbage collector is going to work. There we go. So when we load a script, we'll get a reference to a function, basically. Like, that script will be a function, and just so the garbage collector knows when it can clean up all of the resources from a script, any closures that are instantiated within that function will be referenced here, so that when we drop this function, there will no longer be references to the other functions. So when we mark and sweep the garbage collector, we can clean up the other scripts. Garbage collectors make thing easy. I see why people use them now. When they're making a language, you want to avoid them when you're not writing languages, because garbage collector slow, pause program. Extra work that the programmer should have done instead. But when you're being a lazy programmer like I am, you create a lazy language like this. I genuinely think this is everything we need to define here. Now let's create VM RS. This will run our code. And I think it will be our virtual machine's job. It will be our virtual machine's job to load functions. To load scripts. Oh yeah. That's like, if I were to code in C for the rest of my life and I could take one feature from Rust with me, it would be discriminated unions and the pattern matching to work with them, which I guess is 2 features, but they're kind of like a 2-for-1 deal. They're just like match statement enums. Just kind of the idea behind what I'm doing right here. Okay, so let's create pub struct. This is our virtual machine. Maybe we add threading support at some point. I don't really feel like it at the moment, though. I don't even want to think about that version of Java. No separate variant and separate file. Inheritance is... Don't like inheritance. doing on time? I am doing really well on time, actually. Now we're just going to define everything directly in the virtual machine for now. Virtual machine will be single-threaded because we're lazy. Blank file paralysis. What are we doing here? Implement virtual. We're gonna have load string and load file. Load string is going to be called from load file. Time to add this error. So we're not adding anyhow. I've matured past that point. We're adding a library to make defining errors easy. Create a public enum load error. Maybe. I don't know. I have my own ideas about how to handle error reporting. Mainly what I'm going to do is I'm going to copy the really nice formatted output system that I wrote for the other scripting language I wrote. Great, so with this error, so you use both on the same enum struct. Alright, what's the name of this over-engineered crate? I'll at least look at it. I'll at least look at it. Oh yeah, this is over-engineered. I know, but like, I genuinely don't want to use these ASCII characters here because not all terminals display them correctly, and I get into weird situations where like Like, I have embedded terminals inside of Windows PowerShell and stuff, and I just need to, like, have it be as simple as possible. And they probably have, like, compiler flags for that, but you must enable the fancy create feature to get report output like the screenshots above. Okay, so I don't have to turn it off. I have to turn it on if I want it fancy. So before I have worked with the Chomsky ecosystem, I decided I didn't want to work with Chomsky anymore. I just wanted to straight up write a parser from scratch because it was easier to reason about and debug with. How does this deal with snippets? Here's my error, here's the source code, the highlight, different snippet. With this, do you have to define a different structure for every single type of error? I guess I was already doing that with like an enum variant, but yeah. Ports enums? Okay. There it is. It was kind of like this error. Yeah, so if I want more detailed error, I have to be in there, which I don't know how detailed of errors I'm going to be doing, but downside is the multi-errors are a bit tricky since it considers the source code just one blob of text, but it is possible to do. That's a problem I solved with my error emitter that I figured out. That's another good question. How does it emit functions? I actually do think I do like having structures for errors instead of what I was doing before, which I was kind of inspired by the whatever the partnered crate to Chomsky is, which it uses for emitting errors. I kind of made my own version of that. What does the diagnostic derived macro do? Source code. How is source code defined? Presents the readable source code of some sort. This trait is able to support simple source code types like strings, as well as more involved types like indexes into centralized source map like types, files, handles, and even network streams. If you can read it, source it, it's not necessarily read all. I think you should be able to support. You'd be able to support source codes of gigabytes. So what implements source code? String U8 string back U8 that, and I'm guessing if I implemented source code for my own types, that would work as well. The virtual file struct and a custom span type that holds file ID, and then start end-to-end in that file. Implement the new traits to make it to work like that. Okay, I'm mostly... This is a lot closer to what I want than what I have been using. I want to see what does the non-fancy output look like, because I'll probably be using the non-fancy output. If the not fancy Yes. Yeah, that's the example output. What if I don't? This needs an example of what it looks like when you don't have the fancy flag on. Let's have an example. Fancy. Well, diagnostic. Because if fancy isn't enabled and it just prints out like not formatted stuff, then I don't know if I want to use that. If you want you to render spans, I think you need fancy. Okay. That might actually be a deal breaker for me, because this is too fancy for me. What I much prefer is something like I could just look at see, what's the one I was using before? I wasn't using term color. It wasn't code span. Yeah, model training lets you opt out. I'm gonna look into that after stream. If I look at compiler here and I look at emitter, I might just copy this emitter crate, which is using, okay, it is using annotate snippets. So I'll show you exactly what I want the output to look like. Not fancy is closer to what you want than what this error does. But you can fully control the characters and colors used in fancy rendering. For example, there's a built-in theme that only uses ASCII and no fancy Unicode stuff. Yeah. I'll show you this. Wait a second. This is also using an older version, because it doesn't do that. 11.5. Did they make this fancier? Yeah. See, this is what I wanted it to look like. This is what it looked like when I was using it. Apparently now, they made this one fancy too. That's actually funny. That's really funny. Well, if the crate that I was going to use is making itself more fancy than I want it to be, here's what we're gonna do. We're going to we're gonna clone this. Is the language model going? We're not making a language model. We're not making a large language model. We're making a coding language. Big difference. One is extremely manual and increases your workload. The other one is automatic and increases your workload. So there's a specific flag you can do to run an example. Cargo run example, and here's our examples. Here's Saturday JSON. It's requires the feature fancy. What? How do they say what features they need for the example? Is that defined in the cargo? I've never defined examples for. Oh, where's the where be the tonal? There it is. I'm blind. Examples. Required features. Yep, there it is. Right, can't restore session. So we need to go to this file, not that file, this file. Comment out the required features. So... Oh, low colors. Let's see, so fancy base. Terminal size, supports color, supports Unicode. Fancy no backtrace. Dependency backtrace. Text extension. Detect highlighter. So I might try this out after we run this. Let me open up a new terminal so I can have multiple tabs here. Then cargo run example. What was it? Saturday. JSON hello. We're currently testing out a error reporting library that someone in chat has recommended to me. And it seems like a good library. Okay, so let's look at the format of this error. The error is what we wanted to see. So, as is, with no features turned on, it looks like a regular Rust error. So now let's start enabling feature flags. So if we just turn on straight fancy error reporting, I forgot that I can just do that. So I'm actually going to unrequire it. Which that adds a ton of dependencies. As you can see, the error is a lot more fancy, but this is too fancy. I don't want it to look like this. So if we just turn this to syntax highlighter. What does that look like? It does not require the feature fancy. Okay, that still looks exactly the same, so that's still more fancy than I want it to be. What if we do fancy base? We're gonna do supports hyperlinks. I like it supporting hyperlinks. I like it supporting color. I don't like it supporting Unicode. That did not work. We'll try just fancy base and see what that looks like. What's Unicode? There we go, that's closer to what I want. I do at least want color. Can I add color in? I want everything but Unicode, basically. Okay, we'll try that then. Let's manually edit the example source to see how we can turn that on. Because into diagnostic is just from Saturday error. Where's from Saturday? Okay, so it's mapping the error. Got it. Let's see. It's a diagnostic. I'll actually look at the docs for this. Help level. Handler options. Here it is. Let's copy this. This would set Unicode to false, context lines 3, tab width 4. That looks good. Did I nuke the... I don't know what it's doing here with the open and close braces. Actually, that's the 2 lines of context, isn't it? So this is like the... Yeah, this is the source code here, which is JSON. Alright, this'll work. Spent too much time debating on this, but okay, yeah, I do like this. Thank you for recommending it. Even if I am slightly annoyed that I burned a little bit of time on it. But yeah. Do I smell this? Mite. Oh. Wrong directory. I cannot spell this. There we go. Oh, see, here's the thing. I've already written something like that myself. So I would have just been bringing that in. But this is better ergonomics than what I wrote. Because you do it on based on structs. It does not have this error as one of the options. There it is. Okay, so now we have load error. We need to reference IR function IDs in our virtual machine. Return a function ID. See, me trying to do my proper grammar. Say file load failed. This is gonna be from gonna be an IO error. Maybe it would be, yeah, I think if I do let source equal need to string Then if we read this, size for value U8, read to string, as ref path. It can also be fancy. Not implement display. Saying IO error doesn't implement display? Load error. Just add it and then it will work. I know, yeah, there it is, IO error. Throw in the IO error, and then we actually need to create good errors for the tokenizer. If it even has errors. I think it does, yeah, unexpected char. Actually, this is probably where we would want to use Mite. Isn't it? Does it make sense to add source code to the error message later? One option is to use the with source code method for that. Error with source code. Yeah, that makes sense. What's this code here do? Mylib random error. Mylib random error. What's this error do? Oops, my bad. It's like the namespace of the error to make it easier to deal with. Then here it doesn't have code set. We delayed source code on this, at least for now. Completely skip over what that's doing. But I do notice it's missing from all the ones where we set the source code later. Can I get this done in an hour? it's possible if I super lock in. Gonna straight pass through the formatting there. So we capture file load errors, we capture Elixir errors. Now we have our list of tokens. Means now I have to do all of my implement the virtual machine parser stuff inside of this implementation, since Rust is cool and they let you do multiple implementations, and I've never used that feature before, but I feel like here I want to have one section for publicly accessible things and another for like all our utility stuffs. So here I'm gonna say I want to treat this as the inside of you parse a function body. Would this still be a load error, or would this be a parse error? I think this would be a parse error. And we'll define these later as we need to. Okay, so this is essentially our script here. So we're going to create a new function. Explicitly define this as IR function to differentiate it from any other things we might do. The body of this function is going to be result of parse function body. Is going to result in a vector of IR operations. To do self. This is going to be root self function. Gonna pass in the tokens. Then we're going to pass in the function. And the result must be a unit, and if this completes successfully, the result, we just know that this function is valid. We'll have a public function load function, and this will take in the function to load. And it will return a function ID. In here, we'll need our first property pub, actually not public. Lab functions. Now when we parse our function body, just pass in the function and arguments. No, it doesn't. Oh wait, it does. Needs the tokens. Tokens iterator to be precise. I don't need to worry about the garbage collector yet. We're gonna load the function. The future. Yeah, I don't know. We'll figure it out when we get there. Okay, use size. Function ID is use size. We're good to go. Successfully can go through all the steps of loading a function, and then we have a function loaded, and then at some point we can call that function. We need to implement the virtual machine. First, we need to figure out a way to parse function bodies. That's fine. Don't worry about that for now. Yeah, we'll just call it parse script for now, because I don't want to recursively do parse function body. Parse function body is a different thing. We're just going to do parse function. And these values actually... Except for... let's comment that out. Let's yoink all of this into here. Let's make sure there's absolutely no errors in main that could mess up our submodules having errors. Okay, we're good. And again, I think that's only a problem with crates, but I've run into a lot of problems there before that I don't want to have to deal with here. think the display for values is going to be implemented on the actual virtual machine itself. We have object IDs. Turn IDs. Symbol IDs. Now that's all we need, though for this function, we actually have closure instances, because we instance a function and it becomes a closure, because the function instance can capture values, therefore it's a closure. So the closure, I guess we just have a closure ID. This needs to be an execution error there. We're gonna have closures, objects, arrays, strings. We need a symbol map to be able to quickly check if symbols that already exist. To do that, I actually need to account for scopes when I'm parsing. Is that a runtime thing? I think that's a runtime thing, so I don't need a parse state. Or runtime of the compile time. So none of these are actually used yet. So this evaluate function is the beginning of our parsing. So while let some tokens peak, we need to self-parse expression. Aw dang, why did it define it up there? I want it down here. Okay, so this is going to be this is the main parse errors unexpected token that's going to do basically all of the heavy lifting. I wish they showed so many more examples of what's going on. That's cool. You can link directly to the generated documentation of that error. That's extremely clean. Not very readable for users of like the end language, because like it'll be right next to source like Rust documentation source like API, and someone trying to learn a coding language doesn't want to see the source code of the coding language. No, that's cool that it supports that. There we go. Delayed source code. Let's add source code to the error message later. One option is to use the with source code method. So error type error span into get source code here. Okay. So label is the way that I create a span. So we have an unexpected token at here. Source attribute build that usually comes from this error and implements a method for this error source. Source in many cases, but it's lossy. If the source of the diagnostic is the diagnostic itself, the source will simply be treated as a standard error. You don't know all possible errors up front. Need to serialize, deserialize errors you may want to use. Emitting and diagnostic macros. Create diagnostics on the fly. Oh, that's cool. Let's see snippets. It's the highlight. I wonder if I can do something fancy. And if I say got expected join like that, why not implement toString for tokens? Probably not. Implement display for token. Means to string should be implemented for token. There we go. Screw it. We're not doing tokens. Doing string. Just to make it easy. Well, that's supposed to make it easy, but that's quite the micro statement right there. But I think that works. So I'm really like kind of burning down right here, or burning out. Out of energy. That's what I'm going for. We're making good progress. Didn't get as far as I had hoped. Because large parser refactor and spent a fair bit of time on error reporting stuff, which is good. It's good to spend time on error reporting stuff. It is annoying how long you have to spend on error reporting stuff if you want it to be good. But I think I'm going to sign off now, just because I am very tired. I'm going to go to sleep, and then I'm going to wake up in the morning, probably work on this a little bit more before work. But, yep. Thank you to those who tuned in. I will see you next stream, which at the latest should be Tuesday. Yeah, Tuesday. I would say maybe a weekend stream, but I'm going to be dropping the valve body out of my car and swapping it. This is the last thing I try to do to my car before just trying to sell it or scrapping it. So hopefully that goes well and I get to keep my car. But yeah. Till next time.